Hi! Today we're going to do some trigonometric problems. Let's say we have a problem like this. Given that lines BC and BD are tangent to the circle A at points C and D, find the length of chord CD. So, before we get started with this problem, let's first look at the graph. So we have a circle, circle A, which has a radius of 3, and we're supposed to find this length over here. Let's say this length is Z. So now let's go and start with a few things that we know. So the first thing that we should do is we should connect the center here with the point where it intersects with the tangent. And same for the other tangent line. So we know that at the point of tangency, the tangent line and this radius, where it intersects the point, so where the radius hits the point, the intersection of those 2 points is perpendicular. So we have, let's not draw this line for right now. So we have a 90-degree angle, 90 degree, and 90 degree here. Now let's think about something else. If we're starting at the same point, and we have these two the same length, so these we know, because this is the radius, we know that the distance from the center to any point on the circle is going to be, in this case, 3, which is the radius. So because we know that these two are the same length, and these are 90 degrees, and the fact that they're starting from the same point, we can infer, using intuition, and we can infer that this is also 90 degrees, and that these are the same length. If this is, let's not do that. So let's say that this point still, so let's say that this point, actually no. So yeah, so if we know, so given that we know that this is 90 degrees and they're starting from point B, we can infer that this would also be 90 degrees and these be the same size. So let's go ahead and start. So we want to find this length over here. And this is, let's say, length Z. And so this is where the entire part of the problem comes in. So this part beforehand wasn't as important. Or it wasn't as important in this video. So the problem still is important. So we have, let's say this is the length Z. And we know that these two are 90 degrees. And because this is a four-sided figure, and three of the angles are 90 degrees, we know the other angle also has to be 90 degrees. And so that means that the total measure of the other angles is 180 minus 90, which is equal to 90 degrees. Or sorry. So we have, yes, which is equal to 90 degrees. So that's the total measure of this angle and this angle here. So that means that the measurement of one angle is just 45 degrees. 45 degrees. And if we put another line down the middle, we see that we can come up with a right triangle. This has to be perpendicular to chord Z. So we can see that we come up with a right triangle. And we know that, so let's draw this out here for a better view. So we know this is length 3, the radius, so 3. We know this is 45 degrees. We know this is 90 degrees. And so that means that this is also 45 degrees. And so what do we do now? Well, we first want to find what half of Z is. So let's label this part as X. So we want to find out what X would be. So here's what the trigonometric part comes in. We know that cosine of 45 degrees, you need to make sure that you're in degrees mode, not radians on your calculator. would be equal to adjacent, or x, over 3. And now we know that x is equal to half of z, or z is equal to 2x. So cosine of 45 is equal to x over 3. That means that x is equal to 3 times cosine of 45 degrees. And this means that 2x, which is equal to z, is equal to this times 2, or 6 times cosine, not sine, times cosine of 45 degrees. So the answer to this problem is 6 times cosine of 45 degrees. And in this problem, to get the answer, we had to know beforehand that these two are the same size. So that wasn't the problem. I'm sorry about that. So once again, the answer to this problem is 6 times cosine of 45 degrees. Today we did some trigonometric problems. Thank you for watching this video.